Hello and welcome to 2.1 Solving Inequalities in One Variable. Before we get started into individual problems, I do want to remind you that any time that we multiply or divide by a negative number, okay, we have to remember to flip our inequality sign. So multiply or divide, okay, by a negative, we have to remember to flip our sign. Okay, so I'm just writing a quick little note to myself up at the top of the page there to help remind me of that. Okay, so now what I need to do is I need to solve this. Now, for the most part, when we're solving these, we can treat this just like any other equation. You just have to think about the fact that, if you're multiplying and dividing by a negative, you have to flip the sign. So just like normal, we're going to subtract 17 from both sides. And that gives me that 5x is less than a negative 15. We're going to divide both sides by 5. To get that x by itself. So x is less than a negative 3. Notice I didn't have to flip it because the number I moved, so what I was dividing by, was positive. So now at this point I need to graph this. So to graph it, I'm just going to go one below and one above. Okay, so x is less than or equal to, just less than. So that's an open circle. And then a negative 3. So it has to be less than that. So what numbers are less than negative 3? Well, those numbers are to the left. Okay, for number 2, okay, here we have a number being multiplied by our variable, and the way that we get rid of a fraction is to multiply by its reciprocal. So I'm going to multiply by a negative 3 over 2. Okay, when we do that, this side cancels each other out. Now we multiplied by this negative, so that means we have to flip our sign. Okay, so we flip our inequality. Okay, now we have just x left on this side, and on the other side, if we do 8 divided by 2, it's 4, times a negative 3 is a negative 12. Now, if you want to write that out in 2 separate steps, that's totally fine, but I just did it in one. So now we have x is greater than a negative 12, so negative 13, negative 12, negative 11, open circle at the negative 12, and then x has to be greater than that, which those numbers are going to be to the right. Okay, number 3, my first step is I have to distribute this 3. So 5t is less than 3t minus 3 times 2 is 6 plus 2. So I'm going to combine these like terms of negative 6 and plus 2 to get minus 4 over here. So I have 3t minus 4 on that side, and then we have our 5t that we brought down on the other side. We're then going to subtract 3t from both sides, which leaves us with 2t is less than negative 4. We can then divide both sides by 2, and we get t is less than negative 2. So this is right in line with solving single equation or single variable equations that we did before. So again, this is negative 3, negative 2, negative 1. We put an open circle at negative 2, and then we're looking for the numbers that are less than negative 2. The numbers that are less than negative 2 go to the left. Okay, on to number 4. Okay, again, we need to do some distribution here, so we need to distribute this 2. So this is 4x is greater than 2x minus 4 minus 1. If you have minus 4 minus 1, that's minus 5, so 2x minus 5. So 4x is greater than 2x minus 5. Then we need to get our x's on the same side, so I'm going to subtract 2x from both sides, and that gives me 2x is greater than a negative 5. So then at this point we need to solve for x, so to do that we need to divide both sides by this 2, and you get x is greater than a negative 5 halves. Now when we go to graph this, right, this would really be like a negative 6 halves, negative 5 halves, and negative 4 halves, right? But what we want to do is simplify those down when possible. So negative 3, or negative 6 halves is really a negative 3, negative 4 halves is really a negative 2. So you can really just write this as 3, negative 5 halves, negative 2. The other ones are not necessary. Okay, so then we put our open circle at negative 5 over 2, and then in which direction are those numbers greater than that? Well, that is going to be to the right. So we draw our arrow over to the right. Okay, our next one, again, we have this to distribute. Now, a lot of the time, students forget to distribute this negative properly. So we're going to change this to plus. We're going to change that to a negative, and then we're going to distribute it. So 3 plus a negative 2q, and then the negative 2 times negative 1 gives us plus 2. Okay, and then that takes care of that side. Oh, can't forget our less than 5. So now I want to combine like terms, this 3 and this 2. So 3 plus 2 gives me 5 minus 2q is less than 5. So I want to get this q by itself, so I'm going to subtract 5 from both sides, and that gives me negative 2q is less than 0. I now need to solve for q, so I need to divide both sides by a negative 2. But anytime we divide by a negative, we have to remember to flip the sign. So that means we need to flip our sign. Our q is now by itself because those negative 2's cancel each other out. 0 divided by any number is still 0, so this is still just 0. So then negative 1, 0, and 1. Open circle at 0. Arrow points to the right because to the right are the numbers that are greater than 0. On number 6, we have quite a bit of distribution that has to happen, right? So plus a negative 2 distributing through, and then just the simply negative sign distributing through. So this is going to be 7y plus a negative 2y, and then minus a negative is positive, so that's plus, or sorry, a negative times a negative is positive. So that's going to be plus 8 is greater than 6 minus 2, then minus a negative, which is plus y. So at this point, we need to combine like terms as much as possible. So we have a 7y plus a negative 2y leaves you with just 5y plus 8 is greater than, you have 6 minus 2, which is just 4 plus y. Now we need to get our y's on the same side, so I'm going to subtract a single y from both sides. I'm also going to subtract 8, and that's just because I'm trying to get these y's by themselves. So 5y minus y is 4y, those then cancel each other out, is less than 4 minus 8 gives me a negative 4, and my y's cancel each other out. At this point I need to solve for y, so I need to divide both sides by 4, and that gives me y is greater than a negative 1. Okay, so then to graph that, we need to do a negative 2, negative 1, and 0. An open circle at negative 1. Where are the numbers going to be greater than negative 1? That is to the right, so I need to fill that in to my right. Okay, on to the back, we have 3 more examples to cover here on the back. And so our first example, okay, we have this 5 that's just kind of chilling out in front. That's a positive 5, so to get rid of that, we want to subtract 5 from both sides. So that leaves me with a negative 3/2 r is greater than a negative 9. Now at this point, we want to get rid of that fraction. So anytime we're trying to get rid of a fraction, we multiply by the reciprocal. So multiply by a negative 2/3, multiply by a negative 2/3. Those cancel each other out. We're just left with r. Now we multiplied by a negative, so that means we need to flip our sign. And then a negative 9 divided by 3 is negative 3, times a negative 2 is a positive 6, right? Because negative times a negative always gives us a positive. So now at this point, I just need to graph 5, 6, 7. R has to be less than 6, so we have r is less than 6. So for r to be less than the 6, it'd have to go to the left. Okay, our next one, we need to do some distribution first. So we distribute the 3 on the right or the left side and a 2 on the right side. So that leaves me with 12z minus 3 is greater than 12z minus 10. So then if we subtract 12z's from both sides to get our z's on the same side, that gives me negative 3 is greater than a negative 10. Okay, so our variables are all gone. But we have to look at our statement and say, is this a true statement or is this a false statement? So this is a true statement. So because this is a true statement, right, this is true. Okay, when is it true? It's always true. So this will work for all real numbers. Now, you can't do this when you're doing it online, but if you did this in a homework assignment or in class for me when we're all together, I would allow you to use the little R with the extra bar. That's a mathematical symbol that means all real numbers. So for your graph, right, everywhere on your graph works, it works for all real numbers. So we just fill in the whole graph and just put arrows, okay, on both ends. Okay, on to the next one. Again, we have to distribute first. So this is negative 10 plus R is less than R minus 15. We want to get our R's on the same side. So we're going to subtract R from both sides. And that gives me a negative 10 is less than a negative 15. What? A negative 10 less than negative 15? That's not true. That's never true, right? This is a false statement. Okay, so because this is a false statement, right, that's never true, that means that there is no solution. And because there's no solution, there's nothing to graph. It's just left exactly like that. Hopefully that was informative and helpful, and hopefully you'll do well on your homework. If you have questions, make sure you ask. Have a great day, guys.